So, good day, everybody. My name is Alexey Rusakov. I came here from Tokyo, and my talk will be more like a call to arms rather than the presentation of a particular project, even though I will show a demo in the end, because everybody likes demos. But what I'll be talking about the state of affairs in the area of RESTful API description languages and how our crowd, Qt, and in general C++ is related to it. We'll start with a small audience poll, then I will proceed for the overview of available ADLs from a C++ Qt developer perspective. Then I will briefly give a glimpse of what it takes to write an API code generator in C++ for an API description, and then demo and possibly questions if there are any. So to start with, how many of you actually know about RESTful APIs in general? Okay, pretty much almost everybody. That's fine, already good. API description languages, anyone? And if I say except Swagger, pretty much the same arms. That's actually good, because I was afraid that most people just know Swagger, and that's pretty much it. So, okay, who dealt with the code generated from the API specification defined in Swagger, for example? Anybody? Okay, like a couple. For C++, anybody? Same people. Gorgeous. Did you have documentation and tests generated from the same API description? No. So basically, that pretty much summarizes what we have right now in the C++ world, and how we're positioned against a lot of other ecosystems like Java or Ruby or Python, because those ecosystems basically have quite a good representation of code generators, including documentation and tests for API description languages. Why even bother? Because RESTful APIs are typically easy enough to program already, and also there is that terrific acronym called HATOAS that, in a nutshell, defines that your RESTful API should be self-describing. Means you can connect to a particular endpoint and find out what this API provides, which endpoints are available, what kind of parameters are accepted, etc., etc. Well, to begin with, when you start actually programming against such APIs, you have to write a lot of boilerplate code. Even when you are factoring out all the common, like Q network access manager stuff and things like that, you still have to write actual call invocations and define data structures by hand. Second, there are no static checks around. So build, run, debug cycle only to find a typo in your parameter because you supplied it as a string. You did not supply it as a syntactically checked parameter. This is basically your fate in this case. And what if the API changes? You get the new API specification and you have to update all that boilerplate code that marshals and unmarshals your JSON, etc. Over and over again with every API change. And don't tell me that API don't change. That's a lie. Well, then HATOAS, ironically, can also be represented by hate-ordered API specifications, meaning when you actually have the API which tends to self-describe what it provides, then basically you have no clue in advance what this API provides. So you have to, if any of you dealt with Postman, anybody dealt with Postman? Okay, cool. So what you are doing to discover the API, you write Postman, you issue requests, and you find out gradually what you actually have. Or you can take the API specification, read it with your eyes, type a lot with your hands, and, well, get something as a result. But, again, when the API changes, you have to go through this cycle over again, entirely. Then, it so happened that just yesterday I've had a discussion with FrogLogic folks about static code analysis and formal proving that a particular code behaves. And I realized that, in fact, if you don't have the statically defined code that enforces your API, you have no chance to perform formal code analysis. Because again, those are strings. You know, you form the Q network request, and you have a string for the URL. If you are mistaken there, you are stuffed. If you have mistaken in the parameter, you are stuffed. And so on. You cannot provide any guarantees for code safety in that way. And finally, and it's a matter maybe of convenience, but still quite a considerable convenience, it's very hard to establish any kind of IDE integration. Sure, you can write a plugin for Qt Creator that will read that API specification and provide some kind of handy code completion, but then again, this will be code completion for strings, which is kind of, you know, a complicated thing. And then again, without that, when you are writing that Q network request, you cannot easily determine that, okay, that parameter should actually be supplied. You cannot omit it. And then what does this user /user ID /sepule endpoint do anyway? Anybody knows the word sepule? It's the thing that is done in sepulcharium. So I think you should refer to the internet to find out about that. And that's pretty much exactly what you have to do when you are at a loss about a particular endpoint in the API. You have to go to internet, or at least you have to refer to the specification and hope that the description brings you enough information. You cannot get this information from your ID directly. So that slows you down considerably. That's why using a kind of generated code stubs that would marshal, unmarshal the data, the payloads, would be very handy. However, and I will stay on this slide for a minute, what do we actually have at hand at the moment? Well, the most popular thing is Swagger, and I will go in more detail about the top 3 out of these. It has like an exceptional representation in GitHub, but when it comes to code generation, well, Swagger Code Gen can make C++ client code for you, which is already, well, something. RAML, no C++ support. Again, it could be there. There is nothing preventing from writing such a code generator. It's just not written by anybody. Meanwhile, RAML can be used to produce code in Java, in Python, in Ruby, all modern, all fashionable kids on the block. API Blueprint, basically the same story. With API Blueprint, the situation is a bit more tricky because the language itself is more or less targeted at designing API rather than subsequent documenting or testing or reverse engineering APIs. Nothing like that. So probably it would not be so necessary to write a full-fledged code generator for it, at least with the current state of affairs with the description language itself. However, well, we do have a parser for that. I mean, you can actually download the code that would generate a parser into a particular structure called API elements. And then it's up to you to use this API element structure in your code to interact with the API in this or that way. So that partially solves a problem of, for example, code analysis, because you have the actual structure, but it doesn't really solve the problem of, for example, IDE integration. Other contenders which are listed here, as you can see, are much less represented on GitHub. They are much less popular. And except open data from Microsoft, none of them have any whatsoever support for C++. You just cannot get a code generator for C++. Besides, most of these are actually right now, well, almost unused. So now for the top 3, just to give you an introduction, what we're talking about, what are these API description languages in a nutshell. Swagger, this is the most popular API description language, period, full stop. It's by far like, the next contender, I guess, is 5 times less popular, at least on GitHub. It supports both YAML and JSON to define your API. You can see the example that is taken directly from Swagger.io on the screen. What it defines is basically a set of endpoints along with used verbs, along with properties that refer to a particular endpoint, what it produces, what it consumes, what parameter, where it accepts, some brief descriptions are provided. Basically, everything necessary to generate the code and documentation and even tests is here. Because this API description language is older than the other 2, it becomes kind of a de facto standard these days. It has the biggest ecosystem. Swagger Code Gen project has dozens of different backends and templates to generate code in basically whatever language you can imagine. There are even kind of esoteric things like Tizen or Haskell or Elixir, basically anything you can find in the list. For C++, there are even several flavors. So you can generate Qt5, you can generate REST CPP, you can generate Tizen again. The license actually for all of them is pretty permissive. RAML. If you look closely at the example, you will find a notable similarity to what we've had for Swagger. And that's no surprise, because MuleSoft, the company behind RAML, actually pursued using Swagger for their business. But then they took a position that Swagger is not very good in the area of designing APIs. Swagger is exceptionally good to reverse engineer the API. You have the API, and basically by certain actions, you can reverse engineer the entire specification out of it. But when it comes to designing the API, well, Swagger is a bit too verbose and a bit too low level. And besides, JSON is a little bit less human-friendly than YAML, so MuleSoft invented RAML. It can describe both data and operations all within a single YAML structure, or you can make cross-references. In this respect, it's pretty much the same as for Swagger. There is an extensive community, there is a well-maintained specification, there is an ecosystem for Java, JavaScript, Node.js, PHP, and again, there is a vacuum for C++. Now, for API Blueprint, well, the situation is more interesting. API and data, in this case, are described in Markdown. So what you see in this example is basically a Markdown document But at the same time, it's a specification of the API, the formal one. I mean, you can actually validate it, you can actually generate code out of it, do all the technical things that the API specification is supposed to provide. It's very handy to discuss blueprints with non-technical people, because you can easily produce a kind of a rich text, a formatted text out of a markdown, and hand this formatted text to a non-techie person and say that, okay, let's discuss that what you need to list all vehicles, what kind of parameters. And by the way, this particular example is kind of interesting because it refers to an API for a Tesla. So it's actually a doorway to the IoT world. RESTful APIs are used in IoT. The spec for it is actively maintained. As I said, there is kind of an interesting approach from API, from the company that develops API Blueprint, that they are not inclined to provide the end-to-end code generation. Instead, they provide a set of primitives on the output, and they leave you to deal with those primitives to do basically whatever you want. The resulting model still can be converted to the code in Node.js, Python, Java, etc. And yeah, there are projects for HTML docs generation, obviously, because it's very simple for Markdown. The parser library in C++ is called Snow Crash. It's quite of reasonable quality. It produces what it is supposed to produce, but as I said, that's basically all you can get. The license is MIT, but recently API has got acquired by Oracle, so like I don't want to drill into this down, but I don't know what Oracle does with this now. License might change. We know the Sun case. Open data, very quickly, this is backed by Microsoft with all the consequences of that. And it's backed by Microsoft in pre-Satya Nadella's era. So it was that previous generation Microsoft. It's XML-based. The data module is defined in CSDL, which essentially is XML, which is, oh well. JSON is the standard way of passing data around still. So you define in XML which JSON you are going to pass around. Atom is the second best. It's under standardization right now. It's Oasis standard, and I guess many of you know another such Oasis standard backed by Microsoft. This is OOXML. So basically, it's a standard within its own walled garden. It's popular among big enterprise players. Red Hat, SAP, all expose in this or that way APIs in open data, but many are consuming this, but few are exposing. So what to use? Accept open data, because in order to use open data, yes, it does provide the C++ integration. You can generate a server, you can generate a client from that. But once you've done that, you have to download Casablanca. Everybody knows what Casablanca is? It's a Microsoft framework, very extensive, very heavy, which is used for, in particular, for example, JSON affairs and for network interaction in general over RESTful interfaces. So basically, you have to take Visual Studio, which is a huge beast. You have to make kind of a bigger project for your own small REST client, and there you are. Too much stuff. Out of that, you can use OpenAPI to generate code and document existing API. RAML pretty much for everything. API Blueprint you can easily use for designing new APIs, but hardly accept that. So to the practice. Apparently, I won't be able to provide the demo, but at least I will talk briefly about what I've done. Basically, I've done the code generator for the Matrix client server API. How many of you know what Matrix collaboration communication platform is? Okay, some of you already know about it. That's a shame that there are so few of you. So this is a decentralized open communication platform with blockchain-styled persistence layer. So those nodes inside of each of the circles are actually blockchain-styled chains of messages. So it is eventually consistent in a Kafka-style sequence of messages. And those circles are actually servers, and those smaller circles are actually clients. So that's how it is represented. Matrix targets for displacing XMPP. Probably they will succeed, probably not. I don't know. That's not the point. The point is that we have a client-server API described in Swagger 2. So, almost Swagger 2, okay. There are some pieces here that do not really belong to Swagger 2, but other than that, you can produce the documentation, as described on the right part of the slide, from a bunch of JSON files, YAML and JSON files described on the left. And use this documentation to write the code, but we want to generate the code. This is basically how I'm going to use the generated code. There is a QMatrix client project, which I'm leading. It consists of a library and a reference desktop client. It has the layered architecture, and I would really want to generate those jobs classes automatically, because it's boilerplate, almost entirely. Well, isn't this what Swagger CodeGen is for? Well, yes, Matrix.org already uses it to generate documentation, as I described earlier. It can generate Qt5 code, but the generated Qt code is of questionable quality. You know, Q vector of Q string, and then you have the pointers inside of Q vector and a pointer to a Q vector. It's 2017. What kind of code is this? Then Swagger CodeGen is in Java. So you have to download the Maven project, download all its dependencies, and then somehow include it into your CMake or QMake toolchain. Well, okay, still, you might want to somehow use your own templates for that instead. But for your own templates, you have to actually write a backend in Java, write a class in Java, and do the whole rebuild of the whole thing, which implies you know Java. So instead, I actually used Swagger CodeGen to an extent. I quickly got fed up with it, so I've made my own thing called GTAD, generate things from an API description. It's targeted right now at anything Open API, but I started with Matrix. It's extensible on code generation side, means you don't need to write C++ code necessarily to generate the code itself. You only write the template that will be used to generate the code. And it's lightweight. It only uses C++ standard library and Qt core, and in fact, Qt core is only used for file systems operations. So eventually, when C++17 is more or less widespread, you can actually use it instead. Okay, yeah, and YAML and templating libraries are still around, but they are really small. So the whole thing, if you compile it in minimum size release mode, it can be like several megabytes maybe. The architecture looks very expectable. There is a YAML configuration. There are template files. It consumes all that. It gets the API description. And then it produces the code as the result. Since I'm short of time, I won't show the actual code, but if anybody interested, I can show it separately after the session. The current status is the minimum viable product is already there, I'm actually using it to generate some simple calls in libqmatrix client already, and most of these stubs are actually already usable, so it's just a matter of provide additional glue to actually engage them in the working code. The next steps are to cover more or less the whole matrix API, to produce the documentation. Right now, documentation is not passed to the templates, but it will. High-level stubs would be handy, so that I didn't need to do like anything to update my API. Support for Open API specification 3 would be handy, maybe at some point in time. And experiments with QML, because why not? Actually, combined with the yesterday's talking about how you can dynamically stuff QML to your mobile device on the fly, that produces quite a tasty experience. You can get the new API specification, you can generate the QML code, and without whatever compilation, you have the updated API support in your device. So that's pretty much it as of right now. If you have any questions, well, I'm not sure, maybe a minute or two. Otherwise, thank you.